First, you must calibrate the pH meter using the 2-point method before using it to test the pH of the solutions. Rinse the end of the probe with a distilled water wash bottle into a waste beaker, then carefully dry with a chem wipe. Place into a buffer solution with pH of 7 and gently stir without bumping the probe against any hard surfaces. Save this in the meter's computer, then clean the probe the same way before placing it in a buffer solution with the pH of 4, following the same process and saving in the computer. Now you can test for the unknown pH values. Remember to clean the probe before testing each solution and record the data from the meter in your notebook with all significant digits. You should prepare tables with columns for the solution, its concentration if available, and its pH. Make sure to properly clean and store the meter in distilled water when not in use. In a strong acid, the protons will completely dissociate from the anions, leaving no intact molecules in the solution. This means that strong acid reactions only exhibit in the forward arrow in a reaction and do not reach equilibrium because there is almost no reverse reaction, dissociated ions reforming molecules. In a weak acid, only around 5% of the molecules will dissociate into protons and anions. Most of the molecules remain intact in solution. This means the weak acid reactions reach an equilibrium that heavily favors the reactants, the acid molecules, and there is a reversibility between a few dissociated ions and their acid form. To minimize the effects of the change in equilibrium, you can add a buffer solution. A buffer is a substance that resists changes in pH of a solution when small amounts of acid or base are added to the solution. It contains molecules that can either react with excess protons by acting as a base or can donate protons by acting as an acid. For example, in a buffer system of acetic acid and acetate, if there's extra acid added, the acetate ions can neutralize it by reacting with the protons, and if there's extra base added to the acetic acid, can neutralize it by donating protons to react with the hydroxides to form water.